Hello students, welcome. Previously, lesson 6 form 2 topic 3, we were dealing with the first structure of covalent bonding, which is molecular structure. Remember we said substances which have covalent bonding have either molecular structure or giant covalent or giant atomic structure. So today lesson 7, our class will be mainly dealing with the second type of structure of covalent bond, which is giant covalent structure, which is also known as giant atomic structure. So we are saying this structure consists of an indefinite number of atoms which are all covalently bonded together. The pattern repeats itself in all directions, resulting to the formation of giant covalent or giant atomic structure. So next we want to go and see examples of substances that have giant covalent structure or giant atomic structure. There are three in number. One of them is diamond, the other one is graphite, and the third one is silicon peroxide. So learners, for example, if you want to know the type of structure that a substance is having, and that substance you know is having a covalent bond, then you don't know whether it's having molecular structure or giant covalent structure, it is very easy to notice. What you are supposed to remember only are the examples of giant covalent structures, which are only three: diamond, graphite, and silicon peroxide. Apart from these three, the others are having molecular structure. For example, if you are having sulfur peroxide is having a covalent bond because it is having two nonmetals which have been reacted, sulfur and also oxygen. And we said when nonmetals react, they form covalent bonding. So if you have another example, like maybe you're having water, check here, we're having hydrogen and oxygen which are nonmetal. So the type of bond that we have there is covalent bonding or covalent bond. Therefore, the type of structure that sulfur peroxide and also water have is the molecular structure, not giant covalent structure. Because the ones that are having giant covalent structure are only three in number. One of them is diamond, the other one is graphite, and the third one is silicon peroxide. So during the exam, they can even give you something to do with silicon 4 chloride. Then you are told, name the type of structure that silicon 4 chloride has. So that means the answer will be molecular structure, because the ones that are having giant covalent or giant atomic structures are only three: diamond, graphite, and silicon peroxide, not silicon 4 chloride. So if we have silicon 4 chloride, it will be having molecular structure. So we are going to see each of these examples of the substances that have giant covalent structure one by one. We start with the diamond. So we start with diamond, and we're saying diamond is an allotrope of carbon. So what is allotropy? Allotropy is the existence of an element in more than one form in the same physical state. So learners, remember, there are some elements that exist in allotropy form. So such elements include carbon. Carbon is having two allotropes. One of them is diamond and the other one is graphite. The other element that has got allotropes include sulfur. Sulfur is having two allotropes. One of them is monoclinic sulfur and the other one is rhombic sulfur. So even we have phosphorus that has also allotropes, two allotropes. So we're saying allotropy is the existence of an element in more than one form in the same physical state. So what about allotropes? Allotropes are the different forms of allotropy. Or we can say allotropes are the different forms of elements in more than one form in the same physical state. That's what we can say. So next we are saying in the structure of diamond, each carbon atom is bonded to other carbon atoms by strong covalent bond. Remember, carbon is having an electronic configuration of 2,4. So that means it's having a valence electron of 4. So we're saying each carbon is bonded to other carbon atoms by strong covalent bonds. The carbon atoms in diamond form an octahedral structure. So if you want to know the type of structure that diamond has, what you are supposed to know is that we said diamond uses 4 of these 4 valence electrons in bonding. So if it is using 4 of these 4 valence electrons in bonding, multiplied by 2, we are going to get 8. 8 is octa, so we are going to say octahedral structure. In case we are talking about maybe graphite, graphite will be using 3 of these 4 valence electron in bonding. So it will be having 3 times 2, that will be 6, and that will be hexagonal structure because 6 is heg. So we are going to have hexagonal structure. So we are saying this pattern repeats itself in all directions, resulting into the formation of a giant covalent structure or giant atomic structure. So next we are saying in the process, all the valence of each carbon atoms are used in bonding, and therefore non-localized electrons are found in the structure of diamond. So for that reason, diamond will not conduct heat and electricity because of the lack of the localized electron in its structure. So this is the structure of diamond. During the exam, they can draw for you this structure and you are told name allotrope A and allotrope B. So you have to know the structure of diamond from the structure of graphite. So next we are going to go to the second, that is graphite. So we're saying graphite is also allotrope of carbon. Remember we have defined the term allotropes. So we're saying in the structure of graphite, each carbon atom is bonded to 3 other carbon atoms. When we are dealing with diamond, we said each carbon atom is bonded to 4 other carbon atoms. So here in graphite, or in the structure of graphite, each carbon atom is bonded to 3 other carbon atoms. Because only 3 of the 4 valence electrons are used in bonding, the 4th electron is delocalized in the structure. That means graphite is having 1 delocalized electron in its structure, therefore graphite will be a good conductor of heat and electricity. Remember we said all nonmetals are poor conductors of heat and electricity except graphite. And the reason why graphite is a good conductor of heat and electricity is that because graphite has delocalized electron in its structure. The structure that we are talking about is the giant covalent or giant atomic structure. So we're saying the structure of graphite consists of layers in which the carbon atoms are held together by strong covalent bonds forming hexagonal structure. I've explained that earlier on. And we're saying each layer of graphite is held to the other by weak van der Waals forces of attractions. Therefore, they can easily slide over each other when braced, and this gives graphite it is slippery feel, or it is slippery in nature. So we are going to see next how the structure of graphite look like, because during the exam they can draw for you and you can be asked to name the allotrope A and allotrope B. So one of them is graphite, the other one is diamond. So you have to differentiate it. The easiest way to differentiate is that, remember when you're dealing with the graphite, we said each layer of graphite is held to the other layer by weak van der Waals forces of attraction. So we are having here van der Waals forces. But when we're talking about the structure of diamond, all we have is covalent bonds, not weak van der Waals forces. So we go next to the third one, and that is silicon peroxide. So I say silicon has 4 electrons in its outermost energy level, and we are told each silicon atom is bonded covalently to 4 oxygen atoms, forming a giant covalent or a giant atomic structure. And this is how the structure of silicon peroxide look like. Learners, that is the end of our video today. Thank you for watching.